microphone is on mute and feel free to turn on your cameras. Just to let you know, all participants are required to join the mini contest hosted by our speaker, Mr. Wong Yen Hong. In order to get the certificate of participation, participants must screenshot their hacker rank as proof and attach it in the feedback form at the end of this workshop. Thank you for your cooperation. Let's have a great session tonight. Hello and a very good evening to everyone. We will be starting soon. While waiting for other participants, please ensure your microphone is on mute and feel free to turn on your cameras. Just to let you know, All participants are required to join the mini contest hosted by our speaker, Mr. Wong Yen Hong, in order to get the certificate of participation. Participants must screenshot their Hager rank as proof and attach it in the feedback form at the end of this workshop. Thank you for your cooperation. Let's have a great session tonight. Hello and a very good evening to everyone. We will be starting soon. While waiting for other participants, please ensure your microphone is on mute and feel free to turn on your cameras. Just to let you know, all participants are required to join the mini contest hosted by our speaker, Mr. Wong Yin Hong, in order to get the certificate of participation. Participants must screenshot your hacker rank as proof and attach it in the feedback form at the end of this workshop. Thank you for your cooperation. Let's have a great session tonight. All right, everyone. Welcome to the first workshop of Programming League National 2025. I'm Iman Noraina, and I will be your MC for tonight. On behalf of the team, thank you for joining us tonight. Before we begin our first lot for today, I would like to briefly introduce our speaker, Mr. Wong Yin Hong. He is a final year computer science student at Multimedia University MMU. In his recent experience, he completed his internship as a data scientist at Money Lion, where he contributed to machine learning initiatives. Among his notable achievements, Mr. Wong was crowned champion in PLN 2024 and secured second runner-up in PLN 2023 for the open category. He also achieved back-to-back wins as the champion of the Monash Coding League in 2024 and 2023. Without further ado, let's start with our first slot for today with a little introduction to what exactly is competitive programming. It is our pleasure to have Mr. Wong Yun Hong here to lead the session. Mr. Wong, the stage is yours.
All right. Can everyone hear me? Hello. Can you see my screen as well? Hello. Can everyone hear me? Can you also see my screen?
Yes, we
All
can
right.
hear
Okay, okay.
you.
Yeah, got you. I didn't see that. All right. So let me switch the slide first. Okay. So, hello everyone. Welcome to the first workshop of PLN 2025. And today's topic is Introduction to Competitive Programming. So this workshop is beginner friendly, I promise you. However, if you have some experience in CP, I believe this workshop will also be helpful to you. So let's get started. So I'm in speaker for today. My name is Yin Hong. I'm currently a final year student at MMU studying in computer science and specializing in data science. And I was also a data science intern in the machine learning solution team at Money Lion, where I had the chance to work with some of the real world models, which is pretty cool. And during my free time, you find me dabbling in competitive programming, machine learning, and a bit of web development here and there. So before we begin today's workshop, let me just share you a bit of my CP background so that you know I'm not just making stuff up for everything I presented in this workshop. And yeah, there's one thing I need to clarify before I begin everything. So I know a lot of people has a lot of different interpretation for what CP meant, but in our workshop, CP only means competitive programming. It doesn't mean children programming or anything else, so don't get it mixed up, okay? All right, so let's begin. So my CP journey started in 2021, where I basically first got to know CP through YouTube. So 2021 was the year where I entered university. I was just learning coding and I was pretty new to everything. So during that year, I first stumbled upon this video on YouTube. It's about this guy. His name is William Lim. So he basically posted a video on YouTube about him winning Google Kickstart round 8. So this video is 17 minutes long. So I click into this video. I watched the entire 17 minutes about this guy solving problems and reading problems. And I can very confidently tell you that I understood nothing this guy was doing at all because he was just constantly reading problems and like writing codes. Like I don't even know how he did that so quickly, which was pretty insane. And that was basically what got me into what led me know CP. But at that point, I wasn't actually entirely hooked in CP yet because I didn't have enough motivation to get started on CP. So it was until a few weeks later, after I watched this video, I stumbled upon this video. It's the same guy solving that solved that won Google Kickstart a while ago, doing mock coding interview for Google. And this interview was about using competitive programming problem. And that's when I knew that CP was actually widely used in big tech companies as a screening process, like FANG, which includes Facebook, Amazon, Netflix, Google, and other companies. And that basically gave me enough reason to start doing CP because just like every other first year CS student, I had this dream of getting into Google. So yeah, that basically is what got me into CP. That basically gave me enough motivation to start everything. And on the same year, IT Society MMU has basically organized their first connection ever, which is also about competitive programming. So I was still in foundation at that year, and I basically teamed up with a few friends in my foundation year, and we joined the closed category together. And I guess it's beginner luck. We somehow won the competition, and it got my confidence really high up because we're actually competing with we were actually competing with all the students in MMU at the same time, which includes degree students. So you can imagine how it feels after beating people that have more experience than you. So they got my confidence very high up. So what I did next was basically, okay, that entered 2022. Okay, because connection was the end of 2021. So after connection 2021, I got a lot of confidence. I started doing Code Forces. So Code Forces is basically the world, you can say it's one of the biggest competitive programming website out there. And I started solving problems there. And guess what? I got humbled really quickly because the problems of code forces and also the context in code forces is very different from your usual or your typical programming problem. Even reading a problem statement took me like 30 minutes to read it. So leave alone solving the problem. Everything is just too hard for me. So I couldn't really solve any problem. And in every contest I took part in, I almost get like the lowest rank of everyone. And of every problem I solved, I also couldn't solve it. So after this phase, after this incident, I basically entered a phase in life where I started searching the meaning of it because I feel like I'm just not good enough for CV. Maybe I'm too dumb for it. So this is basically one of my lowest a point where my confidence is the lowest during my CP journey because I just feel really dumb, because studying anything can be really hard, right? So yeah, and this phase went on for a while, a week I guess, or a few weeks, and it wasn't. And okay, I finally got back the motivation when I told myself I want to get in Google because uh, I, I remember why I started doing CP in the first place. So I told myself I want to get in Google. So that's what I did. So after this thing, I had like this sudden motivation. So I just started solving problems almost every other day on Codeforces and taking contests in every other day as well whenever I can. And toward October of the same year, 2022, I hit expert on Codeforces, which puts me to the 85th percentile Codeforces. So for those of you who are not familiar with the rating system in Codeforces, it's actually quite similar to the rating system in chess. So, in chess, you have a rating number, and each rating number comes with a title, right? In Codeforces, it's actually pretty similar. So if you have a rating below 1200, you have a title as newbie. And if it's below 1400, you title as pupil, and then specialist, expert, which is what I hit at that time. And then candidate master, master, grandmaster, international grandmaster, and legendary grandmaster. And finally, there's one thing called tourist. So I know many of you may find it weird, like, why is there something called tourist here? Because it doesn't look like the rest at all, right? Like newbie, pupil, grandmaster, and then there's something called tourist. So for those of you who are not familiar with tourists, you know how every sport or every game has that one guy who's just dominant in this sport or game, right? Or just very good at it and no one can beat it. And basically like Magnus Carlsen in chess. So tourist is basically the Magnus Carlsen of CP. So tourist name is Gennady Krakovich. His username is tourist. And he's basically the first guy to reach 4K rating on Codeforces, and basically the first guy to reach 4K rating in the entire history of Codeforces, which is about 15 years long. Because of this, right, the founder of Codeforces decided to name the rating title after 4K, after his username as a tribute. So this guy is just so good. You can basically see, look at his resume over here. You can see that he actually won quite a lot of competition in the past, which includes 6 consecutive champion in Google Code Jam. And the total prize he won in all of the competition is about 400K USD, which is pretty insane. So yeah, this is the goal of CP basically. Just thought that, it's just an interesting fact to share with you if you're interested in CP. And yeah, let's continue in the journey. So, okay, after that, yeah, I joined Connection again in 2022. I decided when we organized their second Connection, which is also again competitive programming based. So that year, me and my teammate, we decided to join the open category because I already feel confident enough, right? I feel like I can compete in the real world out there. So I started joining. So we joined in the open category, and this time we won the second place. And the winning team is actually okay. I would say that we lost fair and square. Being the second place is actually the best we can do because the first place was actually two guys that actually participated in IOI. So IOI is basically short for International Olympiad in Informatics. It's basically the most prestigious CP competition for high school students. So you can basically think of like, math have like Olympiad and stuff, right? So IOI is basically the Olympiad, but for competitive programming, where you basically get to do CP, compete with others in the world in CP. So yeah, these two guys, they're very good, and I think we lost fair and square. So and then in 2023, I basically started participating in local competition, where I had basically my first physical competition, which is Monash Coding League 2023. So was basically my first physical competition because before 2023, all my competition was almost virtual and online. I didn't really have the chance to participate in person. So this experience was very special to me because it's basically my first, right? And yeah, I won it as well, both semester with my teammates over here. And then I also joined PLN 2023 and we got second runner up. I didn't win, obviously, because of skill issues. And then, yeah, in the same year, I also hit Canadian Master on Codeforces, which puts me to 94 percentile on the rating distribution. But this year, I didn't join Connection anymore. Instead, I became the problem setter for Connection 2023 because I think setting problems in CP is something that every competitive programmer wants to do at least once in their entire CP journey to feel more complete. So being able to set problems in Connection 2023 basically is a milestone for me. I feel like my CP journey finally felt complete because I get to set problems. So this experience was pretty amazing as well. You get to see participants solve the problem you set, and the final was very intense as well. So it's very awesome. And in the next year, I pretty much went on a hiatus from CP. I stopped taking part in contests and solving problems regularly because I had other focus in life. I gotta find my internship. I had my academic to worry about. I have like other stuff I gotta worry about. But that didn't stop me from joining local competition. I still joined some of them. And I was also one of the problem setter in Connection for 2024. And then here comes 2025. So this is basically me giving workshop at PLN 2025 right now. And yeah, I feel kind of awesome because it's like I finally get to give back to the community, to teach everyone what I've gained in my competitive programming journey, right? So yeah, that's basically my journey. And oh, by the way, if you have any question, please do feel free to leave it in the chat. I'll check it from time to time to make sure to answer it. So here's the agenda for today. The first thing in this workshop is what is CP, and then we're gonna talk about why should you do CP, and then we'll talk about how to approach the CP problem, and finally we'll have a bit of hands-on section here. Basically we have a mini contest, and you can solve some problems with everything you learned in this workshop. So without further ado, let's begin. So first, what is CP? So competitive programming, or CP, is basically about solving well-known computer science problems as fast as possible, right? And there's a few key points about competitive programming. First of all, competitive programming is not about software engineering. Basically, you're not expected to write maintainable code or write code with really good practices, because the only thing matter is speed. So you want to write your code as fast as possible without all the redundant stuff that you don't have to, you don't need to include. And second, it typically involves using well-known techniques. So in CP, you're not expected to come up entirely novel. You're typically expected to use some well-known algorithm, data structure, or techniques. So you won't be expected to solve some kind of problem like solving world hunger or that kind of problems, right? It just yeah, you typically won't be expected to do any of that. And then yeah, in competitive programming, your solution also has to run fast enough, and it has to solve the judge's test data correctly, right? Okay, so this is basic competitive programming, and I know that this may not be very understandable for some of you that have not experienced CP. So I prepared an example over here to make you better understand what CP really is about. And this problem can basically be found in this link over here. So let me just share the link real quick. Okay. So for those of you who want to attend the problems, you can find them over here. All right, so let's begin. Okay. Oh, oh shit. Sorry. Okay. Okay. So in a CP problem, you typically be given a problem statement, the constraint, as well as the examples. So first, let's look at the problem statement first. So in this problem, we're basically given a string, PLN 2025. We want to reverse it for n times, and then we want to print the final string. So this is basically a problem statement, but in your typical CP problem, you usually won't have such a short problem statement. Instead, they will be pretty long, and they will have a lot of story elements. So this is an entirely shortened version of a CP problem. Just to help you, just to get started, simple first, right? So yeah, this is the problem statement. We're given a string PLN 2025, and you want to reverse it for n times. So we want to find what is the final string. And the constraint is basically something that hints you about how fast your solution need to be. So in our case, n is bigger or equal to 1, and n is also smaller or equal to 10 to the power 18. So this is the constraint for number n over here. And this is an example for test cases. So let's look at the first test case. So when n is 2, the output is basically PLN 2025. And when n is this very huge number, the output is this. Okay, I believe everyone has an understanding of what this problem is about now, right? So let's try to solve this problem. Okay, it's actually very easy. I think almost everyone that knows programming can solve this problem. So you can basically just reverse a string for n times, right? So basically what this code is doing over here. First, we take the input n, and then we also initialize the string s with PLN 2025, and then we reverse it for n times. So this is basically how you reverse a string in Python. So we do this for n times, and then we get the answer final. Yeah. So yeah, that's the answer, right? Okay, does anyone want to give it a try, a guess? Would this solution actually work if I submit this solution to HackerRank right now? Would it actually get accepted? What do you guys think? All right. Okay, I don't think anyone Okay, I don't think there's any time here, but okay, time limit exceeded. Good, good, good. Okay, any attempt? Any else? Any other attempt? All right, if that's it, okay, let's move on to, yeah, let's try to solve the problem actually. Yeah, let's try. You know what? We'll just find out ourselves by submitting a solution. We'll see. So I prepared a solution over here so that I don't have to type it out. Okay, let's try submitting solution. Okay, the first answer is accepted, but the rest of the test cases is taking a while to process. So let's wait for a bit. Okay, it's terminal due to timeout. So yeah, both of you are correct. It's actually too slow. So yeah, basically something called TLE. So TLE is basically what is known as time limit exceeded. It's something that we use in CP when our solution is too slow and it couldn't fit into the time limit given. So why is this the case? Basically, in competitive programming in general, it takes about 1 second to run 10 to the power 8 operation, and obviously in one thread. Because every competitive programming website out there, it only runs on one thread, right? So it takes about 1 second to run about 10 to the power 8 operation. And our the constraint for n is actually as big as 10 to the power 18. So basically, that means that we need 10 to the power 10 seconds in order to finish running the entire code. And this is equivalent to 300 years, which is obviously impossible to run within the time limit, of course. So we need to do better. So in order to solve the solution, we need to notice that there's an observation. Basically, every time the string is reversed twice, it's actually back to its own original form. You can see that PLN 2025, when it gets reversed twice, it gets to PLN 2025 again. And when it gets reversed twice again, it's back to its own original form. The same goes to the odd number. So the reverse form of PLN 2025, when it gets reversed twice, it's back to its reverse form. So this is basically the observation to solving this problem. Basically, whenever whenever n is an even number, you only have to print the original string. And whenever the n is odd number, you only have to print the reverse form. So this is basically the solution. Now let's try to submit this line of code. Okay, wait. All right, let's go back. So we're going to basically check if n is an odd number. So if it is an odd number, only we're going to reverse a string. Let's just run the code first, see if it works. And yeah, it passed. So let's submit. Hey, hopefully, yeah, and it passed. So yeah, this is basically the solution for this problem. And yeah, we call this AC basically. It's known as accepted. So do you understand competitive programming now? In order to help you better understand what is competitive programming, I will try to relate each one of this point with the problem we solved just now. So first thing, it's not about software engineering. In your typical software engineering code, this is how you write code. You have a very intuitive function name and some comments to make you understand the code, and a lot of other things, right? But in CP, this is how we write code because it takes too long to simply write code that has good practices or is very well formatted. So that's why we don't do that in CP. Instead, we just try to write it as minimal as possible because we want to get it done as fast as possible, right? Because time matters in CP. And it typically involves using well-known techniques. So in this problem, we have an observation. We notice that the string actually stays in its own form whenever you reverse it an even number of times. So we use a well-known technique. It's called modulo operator in order to solve the problem. And yeah, running fast enough. So our first solution is too slow, and we got CLE. Hence, basically optimize our solution to run just fast enough to solve the problem. And we also have to solve the judges test data correctly, obviously. Otherwise, it's still wrong. And most importantly, you need to do all the things I said just now while competing with others. And this is basically competitive programming to you. So yeah, right now, does anyone have any question about CP? If you have any question, do leave in the chat. I'll check it out from time to time to answer you. Okay, I don't think there's any question. Let's move back to the slide. All right, so why should you do CP, especially when you're still young? Reason number one, landing your dream job or university. So basically doing CP can boost your resume. CP experience can make you stand out among others, just like hackathon. Everyone takes part in hackathon because it highlights something in them, right? Like building project, their project building skill or their hacking skill. In CP, it highlights a different set of skills, which includes problem-solving skill, data structure and algorithm skill, and also your implementation skill. In fact, many IOI representatives from our country are currently studying at top universities like MIT, Harvard, and NUS. So this is basically an example on why you should do CP. So if you're still eligible for IOI, if you're still in pre-U or high school, you should definitely give it a shot at IOI if you really want to do CP, because it might just change your future if you can actually study in one of this university. You never know, right? So if you want to know more information about Olympiad stuff and other stuff, you can go check out the MSO website. You can just look it up on Google, but the link is also here. I think the slide will be shared to you guys after the workshop, so don't worry about it first. And yeah, but for me, unfortunately, I didn't really have the chance to join IOI because when I discovered CP, it was already a bit too late. So I couldn't really join IOI, which is very unfortunate. And besides boosting a resume, doing CP can also actually help you to prepare the infamous lead code interviews. So the truth is, most companies nowadays, they still do lead code as part of their screening process. But don't worry about it, because because the fact is, the average lead code hard, right, it's only 1500 rated on code forces, which is about 75th percentile. So meaning that you only have to be just as good as here, better than 75% of the people to be able to solve most legal problems. But I understand that 75% sounds like a lot, and it's a very daunting number. But you need to know that 50% of the participants over here aren't actually that active in code forces or CP in general. So if you just spend a little bit more time in CP, you eventually get very good at it. You'll be here in no time, trust me. So yeah, if you're good at CP, you can basically solve most problem in the interview, legal interview, trust me. And besides this, doing CP can sometimes also land you an interview directly without having you to go through the typical online application process where your resume can potentially be filtered out. So basically some competition, they will offer you interview with companies if you did really well, right? In fact, the past PLNs, they actually offer winners a private meeting with their main sponsor. So in PLN 2022, the winners had a meeting with Money Lion, and PLN 2023, the winners had a meeting with My Startup. And in the previous year of PLN, the winners had a meeting with Global Intelligence. And yeah, that's basically reason number one. Doing CP can help you to land your dream job or university. So let's move on to the next reason. Reason number two, it makes you smarter. So this is basically based on my own experience. So before I started doing CP and everything, I was never really comfortable with reading math or algorithm or even applying them. But believe it or not, reading math and algorithm or writing them out is actually very important in computer science, in my opinion, because on a higher level, you actually need to come up with something like yourself, or you actually need to implement something that was already that's in a paper. That's in a paper basically, research paper. So yeah, at that time, I couldn't really understand. I mean, before I started doing CP, I couldn't really understand most of the stuff I was reading in CP books or algorithm articles. And even stuff like this, simple recursion, I really couldn't get it. I was having a hard time to understand all of this, and it makes my brain really hurts. But after doing CP for such a long time, now I can do all that somewhat comfortably. So you may ask, how will this help me practically, right? So let me tell you. Basically, right now, I'm able to read research papers without much issue. So basically, currently, I'm a final year student, where I had to do my final year project. And my final year project involved reading research papers in deep learning, right? And sometimes these papers, they can present really abstract ideas that it's very hard to visualize. And they also have math equation that that's also very hard to interpret, right? But the skills I gained in CP in reading algorithms and being able to visualize them actually helped me to read all these papers without much issues. And beside that, I'm also able to implement my ideas in code very quickly because I can essentially translate my thoughts into code without much issues. So I was able to do all of this thing over here because during my early years when I do CP, it sort of laid out a foundation for me in my final year right now. So this is another reason why you should do CP, especially when you're still young. So in a sense, it basically made me smarter. Now let's move on to reason number three. Oh, sorry, wrong slide, wrong slide. Okay, reason number three. We want to make Malaysia proud because as of now, we only has one grandmaster on code forces, which is the 99th percentile. So the only grandmaster on code forces right now that's from Malaysia is this guy called Ji Song Yo. He's currently studying at MIT, and he's the only guy that's ever achieved grandmaster on code forces, which is from our country. And currently, there's only 263 users on Codeforces that have listed Malaysia as their country. So that basically makes it the 225th country with the most participants, which is quite low if you consider all every other country out there. And yeah, I think we have 0 appearances in ICPC Asia Regional in the last 3 years as well. So for those of you who don't know what ICPC is, it's basically the most prestigious CP competition for university students. So yeah, this is basically why you should do CP. Who knows? Maybe you become the next grandmaster on code forces, from which is from Malaysia, or maybe you help to contribute to the total users in Malaysia, and maybe help to increase the ranking in terms of the country with the most participant, or maybe you represent our country in ICPC. Who knows, right? So yeah, this is why you should do CP to make our country proud. And yeah, that's pretty much all the reason I have for you on why you should choose CP. But I understand some of you may still not be convinced to do CP because obviously, how can we not talk about the elephant in the room, right? No AI. AI is everywhere now. No Gen AI and everything is everywhere now. Everywhere you go, everywhere you see it. So some of you may claim that AI is taking over CP. There's no point doing CP anymore, right? We'll get absolutely destroyed by AI. I will be a fool if I don't admit that this is true to a certain degree, because AI is getting better every day, right? Like GPT or Gemini or Llama, they were solving problems every better than before every day. They improving every day. But the question is, are they really taking over the CP scene, or are they really destroying it? Okay. First of all, let me just tell you first, one thing first. So how AI has started CP is basically because participant basically use AI assistant to cheat on CP problems. They use AI to basically generate solution on the CP problems. In fact, uh, approximately 30 teams were actually caught cheating in Connection 2024, while the previous year only approximately 10. So you can see there's a trend over here. As AI gets better, there will only be more and more cheating cases in CP, right? But I believe this doesn't mean the end of CP, because let's try to look at how chess had gone through a similar phase. Uh, okay, let's start. Yeah, so for those of you who have been living under a rock, chess is basically a two-player strategy game with no hidden info or luck. And Chess Engine started appearing in 1960s. And in 1997, Chess Engine has beat the world champion for the first time. And today, chess is still played worldwide. So you can see that after almost 30 years, the chess engine has beat our world champion. Chess is still played worldwide today. So basically, not only did chess not destroy the game of chess, um, it actually helps to revolutionize the game, because chess engine can think faster than human, right? So they basically help people to discover moves they have never thought of before, because they can compute so fast, that people couldn't really do. They were able to discover some really amazing moves that people that didn't think of before. And besides this, they also help players to improve themselves by providing personalized data-driven feedback to help players to improve based on their previous history on chess moves. So yeah, I believe just like chess, CPU will adapt and also grow. Maybe one day we use AI to generate some really cool problems in CP, or maybe one day we use AI to generate some solution that we never really think of, which is all pretty cool ideas, right? So yeah, I believe CP would not be destroyed by AI. Okay, and yeah, that's basically all I had for section 2. And by the way, everything I say in this section, it's just my own personal take. It's what I believe in, and it's also based on my experience. And by all means, this is not the only way. Some of the things I say, right? Like you should do CP to plan an interview, or solve some really complex problems, right? Doing CP is not the only way to achieve all this, obviously. So do take it with a grain of salt. Okay, so that's it for the section. Does anyone have any questions at all? Okay, no question. Let's move back to the slide. All right, so let's talk about how to approach the CP problem right now. So this problem over here, it can also be found in the contest link I showed you just now. So this problem was a problem from Coalition 2023. It's called Cody and Math. So let's read the problem statement first, okay? So Cody is very interested in math, and he encountered an interesting question during his last mathematics class. So in an infinite sequence numbers, from negative infinity to positive infinity, Cody has been tasked with determining whether it's possible to obtain a sum equal to n by adding the numbers from L to R, where L is smaller than or equal to 0 and smaller or equal to R, right? And R is also bigger or equal to 0, my bad. Yeah, so Cody wants you to find out if it's possible to achieve the sum. Print the values of L and R if so, and if there are multiple answers, print any, and if there's no answer at all, print -1. And this is a constraint. N is basically bigger and equal to 1, and smaller and equal to 10 to the power 9. And this is an example. So when n is equal to 6, the answer is 0 and 3. Now, I understand that, this is a lot to digest, a lot to intake. It can be very overwhelming to just understand the problem. So here I present you a strategy that you can use to understand the problem effectively. So the first step, right, is to understand the problem. So in this step, we'll basically try to first dissect the problem statement piece by piece. Because in this entire problem statement, we have so many information, but not every one of them is important. So we only extract the important ones. So after you do that, you basically get these three things. So given an infinite sequence from negative infinity to positive infinity and a number n, we want to find a segment, which is also a section in the sequence from L to R that sums out to n, if it exists. And another thing is the segment must intersect with 0. Okay, maybe some of you may still not be able to understand after extracting the important pieces. So the next step, what you can do is actually visualize it. So essentially, we're given an infinite sequence over here and also a number n over here. We want to find a segment from L to R such that when you add every number from L to R, it sums out to n, right? Okay, only if it exists. And the thing is, L and R must intersect with 0, right? I guess it's pretty straightforward, right? The problem now. Wait, I'll answer this one later. Let me just continue with this one first. Okay, I believe everyone understand the question now, right? If you don't, just leave it in the chat. I'll clarify if there's anything. Okay, I'm gonna assume everyone understand now. Okay, let's move on first. And yeah, after rejecting the example, you can also try to make sense of the example to make sure that this thing actually makes sense to you. So for this example, we see that when n is equal to 6, the answer is actually 0 and 3. So let's see why is it 0 and 3. So when n is 6, you can actually add from 0, 1, 2, 3, which will add up to 6. So that's basically why 0 and 3 is the answer for 6. Okay, the next step. Now we understood the problem already. It's time to actually start approaching the problem to solve it. So first, we need to know how fast does our solution need to be measured by big O notation. So for those of you who are not familiar with big O notation, or you're familiar with it, let me just give you a quick recap. So big O notation basically describes the rate of change for an algorithm's performance as the input size grows. So as you can see, for O of 1 algorithm, okay, let me just zoom in a bit. So for O of 1 algorithm, as the number n increase, it stays a straight line. Same thing goes for O log n. It almost a straight line, right? But when you look at O n log n, it actually increases quite a lot as n increases. But oops. Okay, but for n square and 2 to the power n and n factorial, it actually increases quite exponentially, I'll say. So this is something important in CP because you need to know how fast your solution needs to be. If you're too slow, your solution would basically just fail. And this is the way we measure the speed of our solution basically. For those of you who don't really know what big O notation is, it's very helpful to go and check out this concept because I think it's very essential in CP. But not knowing big O notation right now won't really affect your understanding in the rest of the workshop. At least not every one of them. Majority of the stuff can still be still be understood if you don't really understand big O notation. So let's move on first. Okay, here's a general guideline on the constraint itself. So basically, when n is smaller and equal to 10, these are the possible complexity your solution can have. And when n is smaller and equal to 17,500, all of n squared is basically the possible complexity you can have. And when n is smaller and equal to 10 to the power 18, these three complexity are the one you can have, right? And here's the thing, possible complexity does not mean absolute complexity. Basically, it doesn't mean that you need to have these complexity exactly, because when n is smaller and equal to 10, actually, any one of the complexity below here will also work. So for example, for when n is equal to smaller than or equal to 17,500, all of n squared will work, all of n square root n will work, all of n log n will work, all of n will work, and all of 1 will also work. So this is basically what it means here. So yeah, now let's try to analyze our constraint. So the constraint in our problem is n is smaller and equal to 10 to the power 9. So in this case, we'll have something like over here. So yeah, this is the one that match our constraint. So these are the possible complexity we can have for our solution. So O log square n, O log n, and also O of 1. Okay, now that we know how fast our solution need to be, let's try to actually solve the problem. So in this step, it's about gathering observation. We want to search for a clue that can actually help to solve the problem. So this is where creativity comes in. So here's basically where you need to start getting creative, think about anything that's possible, think about anything that can help to solve the problem. And these thoughts, these things, they're not that obvious on the surface. So you need to really try hard to think about how can it really help, right? What are the possible things that can really help you to solve the problem? And I understand that this step is a bit whack. That's like no direction at all, right? If you come into this step, you want to think about something, when there's no direction at all, it can be really hard to think about stuff. So here's some tips I have for you in this step. So first off, you can basically break the problem into smaller parts to make sure it's less overwhelming. Because sometimes the problem can have so many different parts and so many different elements. If you think about the problem as a whole, it can be very hard to think about to come up with a solution because it's just so complicated, right? So you basically break the problem into smaller parts so that it's easier to think about a solution. And you can also start with a naive solution, the one that's likely too slow, and refine it from there. So basically, you start with a solution that's like obviously true, uh, and then you try to think if there's any pattern at all, look at its output, or try to analyze it to see if there's any redundancy or pattern that you can get rid of to optimize your solution, right? And third tips is you want to ask a lot of questions. Okay, for example, what if this is true? Or is it true that, something like this? So after you ask these questions, right, try to justify their correctness. Try to justify if they are correct or not. Because sometimes in the process of justifying if something is true or not, you actually be inspired by something, right? You come across something in the problem that you didn't really think of, right? So in this process, you encounter some clues that may be able to help to solve the problem. Okay. So yeah, these are the tips I have for you. Now let's try to actually apply everything here from in this problem. So right now we're pretty much clueless. We don't know anything about the solution. The only thing we know right now is the time complexity we need and also what the problem is asking about. So what can we do now is basically we're going to try a naive solution for the small number of n's. So in this naive solution, we'll generate every possible pair of L and R between negative n and n to see if any one of them sums up to n. So yeah, I understand this is a bit confusing to any of you in front of the screen right now. So I prepared the code here to make sure that it's more understandable to you guys. So let's take a look at the naive solution first. So in a naive solution, we basically first have two loops. So these two loops, they generate every possible pair of L and R. So they generate L from negative n to 0, and they generate R from 0 to n, basically. And for every generated L and R, we'll try to sum them up from L to R, right? So we have a loop over here, then sum from L to R, and then we sum the number to a variable over here. And if the sum is equal to n, we're going to return L and R because that's our solution, right? Otherwise, we return -1. And then this piece of code over here is just about running the naive solution for the small number of n from 0 to 30. So if there's a solution, then we're going to print for n equal to something, the sum from L to R is equal to I. Otherwise, we just print no solution. Okay, so far, does anyone have any question about the problem at all? All right, I'm gonna see everyone understand what's going on right now. So let's get back to the problem. So yeah, after running this code, you actually find something very interesting, right? So you can notice that, okay, wait, oh my God. Okay, you notice that there's actually a solution for every n from 0 to 30, meaning that the the solution may just exist for every number of n, right? And there's also another thing very interesting in this output over here. So we can see that for every n, L is actually equal to n negative n minus 1, and r is equal to n, except for n equal to 0. So let me just show you what this means. So when n is equal to 6, you can see that the number L is actually negative 5, and the number R is actually 6. And these two, when you sum negative 5 to 6, you actually get 6. And the same goes to 7. When n is equal to 7, the number L is negative 6, and the number R is 7. And when you sum from negative 6 to 7, you get 7. So yeah, this is pretty interesting, right? The pattern and everything. So in summary, we found that there's actually an answer for every n from 0 to 30. And we also found a pattern for n equal to n from 1 to 30. So the pattern is when the input is n, L basically equal to negative n minus 1 and R equal to n. But the real question now is, will this always hold true for any n bigger than or equal to 1? Because we only realized that this answer is true for every n from 1 to 30, but we have completely no idea if this will actually work for every n. So let's try to prove it. So the claim is when the n is bigger and equal to 1, the answer will be n negative n minus 1 and r equal to n. So here's the proof. So basically, when you sum up from L to R, right, from negative n minus 1 to n minus 1, you'll see that these part, right, negative n minus 1 to n minus 1, they actually cancel out each other. And you'll be left with n. So this is why that this solution will actually work for every n. Because no matter how you go and do this thing, as long as you follow this pattern, no matter what the number n is, you from negative n minus 1 to n minus 1, they will cancel out each other. And then you'll only be left with n, which is the answer. So let's take a look at an example. Oh yeah, and this also implied that answer always exists. Let's take a look at an example. So when n is equal to 3, L is equal to negative 2, and R equal to 3, right? So let's see how it works. So basically, negative 2 cancel out with 2, negative 1 cancel out with 1, and we're only left with 0 and 3, which is the answer n. So yeah, that's basically our solution. When the input is n, when the input is 0, L is equal to 0, R equal to 0. When the input is bigger than or equal to 1, the number L is negative n minus 1, and R is equal to n. Case. Yeah, so far, does anyone have any question regarding solution? Or is everyone okay with the problem and the solution? Okay. All right. Good, 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 good. Okay, I guess we'll continue right now. All right. So next step, we want to find out if our solution is fast enough or not. So going back to step 2, we found that the constraint in our problem is actually one of these possible complexity. So the question now to ask is that, does our solution fall into any one of this complexity over here? So to answer this question, let's take a look at our solution first. So this is how the code look in our solution. So we take the input n, and then if n is equal to 0, we print 0, 0. Otherwise, we print negative n minus 1 and also n. And this solution is an all of one solution because the number of steps you run in this solution doesn't depend on n. Basically, it doesn't have a loop. So no matter how you go and change the number n, you're always only going to execute 3 or 4 steps at most, right? So first we compare, which is the first step. And then if this thing passed, we print it. Otherwise, we print this thing. So no matter how you change the number of n, it will always run this constant number of steps. It doesn't change at all, even though if you change n. And yeah, warning. We typically don't really type the code out in this step to know how fast our solution is, because if it turns out to be a wrong solution, it will waste a lot of time to go and type this entire thing out and to figure out the time complexity and just to remove it all over again. It wastes a lot of time if it's wrong, right? So basically what we do usually is try to calculate this in the head. Because when you try to figure out a solution, right, you have an idea, how are you going to code this? How are you going to write this thing out? So during the start process, you also be able to tell how fast your solution is. So that's basically what we usually do instead of coding the solution out to know how fast it is. And yeah, so to answer this question, is our solution one of the given constraint? The answer is yes, because our solution is all of one, so it falls into the possible complexity. And yeah, what if it's not fast enough? Okay, if it's not fast enough, you need to go back to step 3, try to think about a solution that will actually fit into the complexity. And yeah, and basically reiterate this entire process until you were able to get a solution that's fast enough. And next step is to basically code and submit. So let me just try to submit this code over here so that you can see that it actually works. Okay, let's go to the second problem. Podium math. Yeah, solution over here already. So let me just try to submit it. Hey, it's gonna take a while because this problem uses a custom checker. So basically, it means that there's no fixed answer for this problem. You can print any answer, and the checker behind this problem is going to check if your answer is correct or not. Okay, it's taking a while. Oh, yeah, it works. So yeah, it gets accepted. So okay, wait. Okay, so yeah, code and submit is basically what you do in the fifth step. So after you're sure your solution is correct and it's fast enough, you just try to implement your idea and then submit it, and then yeah, it gets accepted. And congratulations, because the problem we just discussed just now was actually one of the hardest problem, I guess, in the entire contest in Connection 2023. 80% of the participants couldn't solve this problem, but you guys were able to understand this problem. So yeah, they say something about you guys. And yeah, here's some advice I have for you in CP. So first thing, practice makes perfect. The only way to get really good in CP is to solve many problems in CP. I don't think there's any other way around, unless you're that one person who's really good. Otherwise, stick to solving problems, right? That's the only way to get good. Okay, if you really couldn't think of anything about a problem, try to take a walk or try to do anything that may be relaxing to you. Because when your mind is relaxed, right, you get to think more about the other things basically. Okay, it helps basically relaxing. And if you really couldn't do anything, the next thing you can do is probably just come back later. Maybe go solve another problem first. Maybe you get some inspiration or some clues from there that may be able to help you to solve this problem. Maybe they are similar in some way, right? But if you still couldn't solve the problem, right? If you still couldn't think of anything, just write any solution. Just write a solution that's correct. Maybe it's too slow, but just write it. Don't bother it. You write a brute force solution, the one that's too slow, right? But very easy to code. You write it out and you submit it. If the contest is allows partial scoring, maybe your solution will pass. Or maybe if the tech complexity is actually not, or maybe the problem is meant to be solved using brute forcing, your solution will also pass. But if you couldn't think of a brute force solution, or you couldn't think of anything else, just I'll say just try to submit anything you can think of and then pray. Yeah, this is the only way to make progress, right? Yeah, this is all the advice I have for you in CP and how to approach the CP problem. So by now, does anyone have any question at all regarding CP? All right. No, let me just answer this question first. So what do you think about is the best programming language used in CP? So I think the best programming language to use in CP is probably C++, because obviously it's fast. Yeah, hands down, it's very fast. And because in Python, there's usually a lot of built-in stuff, a lot of redundant stuff, right? So Python is usually way slower than C++. So when you're solving competitive programming problems, your C++ solution might be accepted, but the same solution that you coded out in Python may not be accepted because Python just comes with a lot of overheads, but C++ doesn't. It's very lightweight. Yeah. Okay, any other question about the problem earlier or anything else that we talked about earlier? Okay, if nothing, we'll just move on to the next section. So yeah, this section is a hands-on section because what is a workshop without hands-on practices, right? So let's get your hand dirty. So in this section, I basically prepared a mini contest where it features two problems, and you have about 20 minutes to solve these two problems. And unfortunately, winner doesn't get any prizes, but you do get bragging rights. So this is the contest link. I'll send this to the chat right now. Okay, wait a minute. Wait. Alright, let me just send this to chat right now. Hey, I'll also try to set the time first because this time is yeah. I'll set it to begin in about 5 minutes from now. So it's 54. I guess we'll start at 9. So that's 21, right? Okay. And the end time is going to be 20 minutes after 9 p.m. So hey, wait. All right, save changes. So if you go to the contest page right now, it should be around 5 minutes. So yeah, so the contest will begin in about 5 minutes. So I hope everyone good luck. And after this contest, we'll have another 5 minutes break before we come and discuss the solution. So yep, good luck everyone. Have good luck, have fun.
Just a reminder, this mini contest is mandatory for you to receive your certificate of participation. I hope you guys are ready because the contest will start in 5, 4, 3, 2, 1. Don't forget to screenshot your proof of participation in HackerRank and good luck, guys! The contest will end in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time's up. Well done, everyone. Great effort and commitment in completing this mini contest. We will now take a 5 minutes break. Feel free to stretch, grab some coffee, or just relax for a bit. See you again later. short break help you recharge. Now, we will hand the session back over to Mr. Wong.
Okay, let me just share my screen first. All right, can everyone see my screen? Oh, can you guys see my screen? All right, that's good, that's good. Okay, so let's get back to the contest. So first of all, congratulations to the one and only Deepster for winning the mini contest, and of course the rest of the participants. So right now let's get into the problem discussion session. So we first start with Cody and schedule first. So I believe everyone has already read this problem statement, right? So let me just get to the drawing board. So oops. Okay, so for this problem, right, we're basically given n teams in a competition, right? And we want to schedule. Okay, we want to schedule a competition such that each team plays against two different teams, right? This is basically the objective of the entire problem. So yeah. So right now let's try to make sense of the example first. So when the input is 5, that means when we have 5 teams, one of the possible way to arrange the competition is as such. Let's try to make sense of it first. Okay. Oops. That's okay, yeah. So yeah, this is the output. So when n is equal to 5, one of the solution is actually this. We can play 5 games, and team 3 we play again. Team 2, team 3 we also play again. Team 4 and team 5 we play against team 1, and team 5 we also play against team 4, and team 2 we play against team 1. So I understand that this may be a bit hard. I mean, using this example may be a bit hard to understand what's actually going on. So let's try to model this problem as a graph, right? So we can essentially model each team as a nodes. So we have 5 nodes over here. Wait, it's a bit laggy. Yep, 3 node, 4 node, and 5 node. So let us name this node as 1, this is 2, this is 3, this is 4, and this as 5. So in this case, so 3 will play with 2, and 3 will play with 4, and 5 will play the game 4, and 5 will also play with 1, and 1 and 2. So from this example, we can see that when you try to model this problem as a graph, right, using this output, they actually form a cycle. And it actually makes sense to model it as a graph because when you think about it, right, we want each team to play against two different teams. So when you model the problem as a cycle, you see that, okay, one big cycle, right? You see that each node, they're actually attached to two different nodes, meaning that as long as you schedule it this way, it will always work. Because when you have such a graph, right, each team will always connected to two different teams. So this is basically our answer. So let's try to code this out. Okay. You know what? Let me just give you an extra example first. Okay. So maybe when n is equal to, let's say 4, right? So we'll have node 1, node 2, node 3, and node 4, right? And we'll make 1 play against 2, we'll make 2 play against 3, we'll make 3 play against 4, we'll make 4 play against 1. So basically, this is our competition, the edge basically. So wait. So the answer is 1, 2, and 2, 3, and 3, 4, and also 1, 4. So you can see, yeah, this is basically the solution, and it makes sense and it works. Okay, so let's just get the coding right now. So first we'll accept the input. And for I in range n, I want to print the ith number plus 1 because the loop starts from 0, and then another number, next number basically. Yeah, wait, plus 1, and then modulus n plus 1. Okay, this is basically a solution. The reason why we do mod here is because when I is equal to n minus 1, right, you want to add 1. You want to add, okay, when I is equal to n minus 1, this is n, and if you just simply add 2, right, you get n plus 2. So you want to modulus it so that it stay within the range. So let us just run this code first. Oops. Oh, okay, I forgot to print the number n. My bad. All right. This should work. Okay, it works. Let's try to submit the code. Okay, let's wait for a bit. Okay, it works. So yeah, that's the solution for the first problem. Does anyone have any question regarding the first problem? Hey, is everyone okay? All right, I'm gonna assume everyone's okay. Let's move on to the next problem, I guess. Okay, let's look at the next problem. Cody and rectangles two. Okay, so I'll probably skip the problem statement. Let's just look at this example. I think it's easier to understand. So with this picture over here, and this is our input. So basically, what it's saying is that we have two rectangle. So this is two rectangles, as you can see, a blue one and also a purple one. And the first rectangle, its edge from its vertical edge range from 1 to 3. So you can see 1 to 3. And then the second one is, and then its horizontal edge is 0 to 2. So 0 to 2, right? And then for the second rectangle, its vertical edge is from 0 to 2. And its horizontal edge is from 1 to 3. So yeah, this is basically how the rectangles were positioned based on the input. So what we want to find in this problem is basically how many areas on the Cartesian plane has been covered by rectangles, right? So the answer in this case is 7. Let's see why is it 7. So basically you can try to count each one of them manually. 1, 2, 3, 4, 5, 6, 7. So the answer is 7, right? Okay. To solve this problem, it's actually not that hard, but you need to first take a look at the constraint first. Because notice that the constraint is actually surprisingly small. Okay, wait. Yeah, the constraint is actually surprisingly small. Almost every number here is below 100. So meaning that, okay, let me just propose you a solution first, and then we see why it works, right? So the solution to solving this problem is that we can actually represent the entire Cartesian plane on a 2D array. And then we can simply loop through each one of the rectangle, right? Each one of the rectangle cell and mark it as 1, right? So basically, okay, in this case, let me show you an example. Okay, wait. So in this example, you can assume we have like a Cartesian plane of 0, 0, 0. Oh shit, 0, 0, 0, and 0, 0, 0, 0, 0. So this is our 2D array, right? It represents the entire space. So we'll try to iterate from the first rectangle first. So because the first rectangle covers this position, this position, this position, this position, right? So we'll look through it. So this will become 1, this will become 1, and then this will become 1. This will also become 1. And then for the second rectangle, same thing. We iterate through each cell in the rectangle. So because this one is already 1, so we can ignore it. We go to the next one, and this one 1, this one 1. Okay, the answer is just the sum of this thing basically. So if you count every one in this array, right, it's actually just 7. So yeah, that's basically how you solve it. Now, why this work? Why is this fast enough? Because it looks slow, right? Because we're essentially having 3 loops if you think about it. We're iterating through every cell of the rectangle. That's about n squared, because the rectangle can only be as big as 100 times 100 over here. Okay, wait. Yeah, this is n. This is also n. You think about, if you look at it, n is actually smaller than 100. So if we look through every cell in a rectangle, right, the time complexity is actually O of n squared, because you want to look through every cell in a rectangle, right? So O of n squared. And we have a total of n rectangles. So that makes the time complexity O of n cube actually. But this is not really a problem, because if you look back to the general guideline I provided before, right, you see that when n is smaller or equal to 100, it's actually possible to do n cube, which is our solution complexity, right? So yeah, that's how it works. Let's just get to the coding right now. So let's first get the input, n equal to integer input. And then what's next? Okay, let's get stuff. So this n rectangles, and then get A, B, C, and D. Map. Okay, let's map integer input dot split, and then let's. Okay, this may look a bit confusing. So what this is doing is basically we first try to get input dot split, and then we try to let me just do step by step to make sure you understand. Okay, you know what? Okay, let's just print this one first. input are split. So if you run into code, okay, this is what you get. You see that because input accept the entire line as a string, right? So when you split it with no argument, you basically split across the between every spaces. So this is what you get. But the thing is, when you get to here, everything is still string, so you need to convert it to integer. So we do this by using the map function and with the integer function as like the function that does it. So when you do this, you get a map object. So because we have map object, so we want to convert it to a list essentially, so that yeah, everything is an integer. So yeah, you can see that everything has been converted to integer. So and then we just do this to get every value from there. Okay, and we also need an array to basically represent the entire plane. So we call it frequency array. And this is 0 times 100 because max complexity is 100, right? Or in range 100. Okay, let me just print this out for you first if you don't understand what is it. Print frequency, right? So this is a 100 times 100 2D grid you can see here. So this is what we're going to represent the entire plane, okay? So what we're going to do now is basically, oops, do what we did just now, the algorithm I explained just now. So first we'll, okay, this is only I. For I in range from A to B, for J in range C to D, right? And then frequency I, J is equal to 1. Okay, and let's print frequency first. You know what? Let's try to size down the cell first to see how it looks. So we'll make it 10 here. Also make it 10 here, so it's more interpretable. Okay, you can see that it's actually working correctly. So okay. Oh, wait a minute. You know what? Okay, wait. Is it correct? Okay, wait. Oh, it's correct. Okay, but it looks a bit weird. Oh wait. Okay, yeah, I guess it makes sense. Yeah. It's inverted. My bad. So okay, let me print frequency again. You know, let me set to 5, so that it's more obvious. Print frequency. Okay, this is basically the entire plane. The reason why this is 0 instead of 1, right, is because remember that the array is 0 index, so the entire thing is actually inverted in a sense. So basically, the 0 here represents the cell, and the 1 here represents the cell, and so on. So yeah. Okay, so what this is doing is basically it tries to sums up the first the row first, and then with all the sum of the row, we sum of the column. So let me just show you real quick. Okay, my code. Okay, you get 2, 3, 2, which is the same over here. 2, 3, 2. Okay, then we just sum up everything again, which is our final answer. Okay, run code. And yeah, let's submit. It should wait. Oh my god. I forgot. Sorry. It wouldn't work because I haven't changed the yeah, the map, my bad. I should change this back to 100 because the maximum range is 100. Maybe 105 because I'm worried maybe they may be out of bounds. So let's run code again and submit. Hey, this should work, I think. And yeah, it works. So does anyone have any question regarding this problem? Okay, can you put a thumbs up if it's okay? All right, okay. Thank you guys. Thank you for the reaction. Are these problems considered beginner problems? If you go to code forces, right, this is like the one of the simplest problem you see. It's just this is how it is. I was just trying to get you prepared to PLN because I think PLN is going to have similar difficulty, if not very far away, right? So yeah, I mean, okay, I think this may be considered medium, I guess. Maybe not that easy, all right. Okay, but let me get back into the stuff first. So yeah, I guess everyone already understood the problem, right? So I still have a few things left that I want to talk about before I conclude this workshop. So here are some resources I prepare. I mean that I recommend you to use if you want to really get into CP. So first, if you want something like a roadmap or a guide, right? You can check out Cycle Guide. It's maintained by the 2019 IOI champion, basically the best of the world, Benjamin Chi, BenQ, his co-first username. And you can also check out CS User Problem Set plus CPH. CPH is Competitive Programming Handbook. It's a free book you can get. It's a very good resources. Many competitive programmers that I know, they use these two things together to get really good. And then you can also check out CP algorithm. It's a very awesome algorithm wiki for CP. It basically has a article for algorithm and a lot of proof that's very well written as well. And you have CP books. This one is authored by the NUS ICBC team coach, Stephen Hallam. I'm not sure if this book is free or not, but I think one of the versions is free, so you can check it out if you want. If you just want to solve problems, you can go to these online judges that I know, can the most well-known one. So first we have Code Forces. It's obviously the best one I think you can say in this list because it has a very large user base. It also has a lot of content from time to time. So yeah, this is a very good one if you want to try. And then Coder. It's a CP site based in Japan. Many good problems, but they're also available in English, so don't worry about it. And then Katas. Problems here, but not a lot. I think it's pretty decent UI and all that. SPOJ is a lot of problems, but no quality control. So the problem can be very good or very bad, okay? And finally, we have code chaps. I've personally never did use this OJ, but if you are interested, you can just check it out. So, yep, that's basically it for me for today's workshop. Just want to say thank you to everyone for taking part in this workshop. I really appreciate it. Yeah, I guess good luck in PLN 2025. And here are my contacts. So if you want to find me on Codeforces, you can go to this link on my LinkedIn, on my GitHub. Okay, I guess that's pretty much it.
All right. Thank you so much,
All
Mr.
right.
Wong, for that insightful and engaging talk. Your explanation on the topic truly gave us a fresh perspective. I'm sure many of us picked up new strategies and ways of thinking about problem solving. Let's give Mr. Wong a virtual round of applause. After today's talk by Mr. Wong Yin Hong, I'm sure that the participants might have numerous questions to ask our speaker. The link to submit your question has been shared in the chat box. Feel free to scan the QR code on the screen or click on the link to submit your questions. Please don't forget to include your name in the question. Go ahead and send your questions. Disclaimer, this Q&A session is for those who have questions regarding the workshop. If you have any questions related to the competition, you can ask the questions during the preliminary round. Now, we will give you a few minutes to submit your question. So, Mr. Wong, how many hours did you practice daily to become good at CP?
Okay, so back when I was still doing CP like every day, I think I tried to spend uh free time I had almost like, I don't know, 2 to 3 hours a day, I guess, or maybe even longer than that. Because I'm not that good myself, so I had to do a lot of practice in order to get good. Um, so yeah, I'll say maybe 2 to 3 hours, I guess. But if you really just want to, because like when I was solving problem, right, if I couldn't solve it, I usually don't go look at the editorial or the solution. But that's what suggested by a lot of people. If you're stuck by 30 minutes, you should just go look at the solution. I don't really like that. So what I did was instead I tried to figure it out myself, try my best to figure it out myself before I can answer it. So yeah, that's how I practiced back then and just try to take part in every contest. I think that's a better way to do it is like try to take part in every contest and try to solve every problem that you couldn't solve in the contest. Yeah. Okay, I guess that's it for the answer, I guess.
Next question. I just started CP last year, but I'm stuck in newbie code forces. Do you have any suggestions on what materials I should use to study?
Okay, the material that I suggest is actually the one that shown on the slide just now. I guess you can refer to it after I mean after the workshop has ended. Probably send it to the Discord server. Yep.
Next, how many hours did you practice daily to become good at CP?
That I already answered this question.
Okay, sorry. Next, what are the five famous or must-have algorithm used in CP?
Okay, five famous must use. Okay, first one has to be binary search, right? Binary search is probably the best algorithm out there. Okay, you can look it up on code forces. Everyone would tell you the same thing. You must know binary search. That's a must have, right? And other than binary search, I think if you really want to get okay to reach a decent level at CP, right, you actually don't really have to know about a lot of algorithms because sometimes you're just using the same set of algorithms to solve the same problem to solve the problems, just in a little bit of different way. Okay, so other than binary search, I would say graph algorithm because that's another very common topic in CP. And other than that, I would say dynamic programming. Dynamic programming is not that often when you're starting out, but I think it's a very interesting very interesting thing to learn. I think it'll also be helpful in even in beginner problems. Okay, the last two, let me think. Um, does the sorting algorithm consider an algorithm? Okay, let's just assume it considers as algorithm, right? You need to know how to sort an array basically, because it can come in very handy. You need to sort an array in a lot of problems. So yeah, sorting algorithm is very good. It's very good. Also, maybe yeah, greedy algorithm as well, because a lot of question they require you to make observation about a problem so that you can use something called greedy algorithm. So these are the five algorithms I think you must know. First is binary search. Second is graph algorithm. Third is dynamic programming. Fourth, sorting. And final one is greedy algorithm. Yep.
All right. Next, is there any roadmap or categorized questions that you recommend?
Yeah. So if you go into USACO, okay, if you refer to resources I shared just now, a lot of them actually has like structured categorized question, okay, whatever it is, right? So yeah, you can just check out those resources. I think it has a very good roadmap, I guess. I think it has a very good resources. You can just check it out, eCycle Guide. It's the one I use personally, so I definitely suggest that one. That's it. Yeah.
Next, is fast I/O necessary for CP?
Yeah, I think FastIO actually is necessary for CP, but I guess on a higher level, because maybe not on a higher level, I guess. I guess it depends. Depends on problems, but it's best if you have it because some problems when you didn't use fast IO, right, it actually takes a lot of time for your code to accept input and to also print something as an output, right? These bottleneck can be essentially removed by using fast IO or whatever you call it in your language. Yeah.
Next question. What would you do if you're really stuck on a problem?
Okay. Okay. If you're talking about when you're practicing, here's what I usually do. I solve a problem, right? I try to think of it for hours, right? I mean, for an hour first. I try to write down everything I can think of. If I really couldn't do it and I'm really exhausted, I'll just take a sleep, take a nap or whatever. Because usually when you sleep, right? When you get up, it's like the idea will come out immediately. I don't know why. Okay, it just happens. So if you're in a practice, right, just sleep, take a nap, whatever. Maybe you'll figure out a solution when you wake up. That's what happened to me a lot of times. I don't know why. Maybe I'm also dreaming about a problem. I don't know, bro. But like, yeah, that's what I usually do. But if you want a more realistic approach in terms of competition, you can probably take a walk. Yeah, I think take a walk helps a lot because it feels really stressful at the moment. But when you do something relaxing, it it relaxes your mind to let you think about more stuff. So yeah.
Okay. Next question. What other platform for CP would you recommend excluding HackerRank?
Okay, in terms of platform, I think it also depends on what you aiming to do with CP. If you just want to do for interview and all that, I think going to code forces may be a bit overkilling. So maybe you just want to try leak code. But if you really want to ace every leak code problems out there, and you still want to okay, and you still want to get a leak code or whatever, you can try code forces. Code forces is the one that everyone is using. So yeah.
All right. Next question. Have you ever heard about ProSolve National? Is it the same with CP?
No, I have never heard of a pro soft national.
Okay, next question. Do you think it is okay for students to normalize ChatGPT?
Okay, this question is a bit tricky. It's because like I think GPT is really helpful in a sense, because it helps to learn, right? I mean, when you don't have someone to ask, someone to mentor, it's GPT is the go-to thing you ask, right? So I mean, that's what I do as well. I ask GPT things, but during contests, right, I don't really do that because I think it's a bit unfair to because a lot of participants they put a lot of time into practicing, right? If you just use GPT to beat them, uh, for whatever reason, I just don't think it's a right thing to do. So maybe use GPT correctly, okay? Use it to learn, use it to whatever, okay? Just maybe when it's not supposed to use it, just don't use it, okay? I think that's the suggestion I have for you, I guess. Maybe and don't rely too much on GPT because when you rely it to code for you for every time, you won't really learn anything. So my suggest is maybe just use it when you really need to. Yeah.
Next question. How to join Code Action?
How to join connection. I think there's also a connection toward in December this year, but it's no longer competitive programming based. I think this time it's gonna be a hackathon. Because you want to try something new, right? So yeah, that's how you can join. I think you just follow connection page on Instagram. You see it when they started to promote the events. Yeah.
Next question. Are there cases where you woke up but the solution still didn't pop up?
Yeah, actually, it occurred to me a few times. I hope it worked every time, but it doesn't. Okay. So when this happens, I try to think of a solution again. But if I really couldn't think of it, right, I just usually leave the problem first. Or if I'm really desperate, I'll just look at a solution and try to learn from there. Um, from people I know, they usually just don't look at a problem for a few days or put it away for like a few weeks and then only get back to it. And after that, and sometimes you may have like inspiration or some clue that you didn't have at the time. Yeah.
Next, are you still the problem setter for Code Action 2025?
Okay, like I said, Conation will no longer, I mean, at least for this year, it would not be a competitive programming competition. It would be a hackathon. So no, the answer is no. Yeah.
Next, would you continue CP even after you graduate, or will you hang up the mantle?
Um, Yeah, I do CP as like a hobby right now. I don't really do it as competitive as before because my initial goal when I started CP, right, was just to reach Canadian Master on Code Forces, and I did that. Of course, I want to reach Grandmaster as well, but I think that's very unlikely for me now, especially considering that I don't have time and to practice and all that. So maybe just as a hobby, do it whenever I want, whenever I'm free, but not striving to get a better rating in a sense, if you get what I mean. Yeah.
All right. Final question. What is the toughest challenge you have gone through on this path?
And the toughest challenge is definitely solving problems because the problem is like sometimes it can makes you want to pull your brains out. It's just so hard to understand sometimes. But I think the toughest one is probably starting out in CP because I think starting out in anything is equally difficult. Just that, yeah, because the reason is that when you're starting out, right, you're not comfortable with all the things you see, so you'll be a bit overwhelmed by the entire CP scene. But once you get used to it already, you know how to write code, you know how to think, you know how to solve the basic problems, and you just take part in contests regularly. After you get used to this thing, right, it'll just be more of a smooth sail after that because you know what you're doing, you know how to improve, you know what you're doing is right or not. So yeah, I think starting out is the hardest part for me. All right.
All right. That brings us to the end of our Q&A session. Thank you once again, Mr. Wong Yin Hong, for addressing our questions with such clarity and making Programming League National 2025's first workshop a success. And to our participants, thank you for being so engaged and asking thoughtful questions. So, before we end, let's capture this moment together. Please turn on your cameras and we will take a quick group photo. Biasanya kita gede. Hmm. All right, everyone. Big smiles in three, two, one, cheese. And now freestyle shot. Show us your excitement in three, two, one. Thank you, everyone. All right, so that brings us to the end of the first workshop of the Programming League National 2025. Thank you once again to our incredible speaker, Mr. Wong Yin Hong, and to every one of you for your participation tonight. Before you leave, please remember to fill in our feedback form via the link that we have shared in the chat box or scan the QR code on your screen. Upon completion, you will receive your certificate of participation. Your feedback will really help us improve our future programs. And don't forget to mark your calendar for the second workshop happening on 26 April 2025 from 8 p.m. to 10 p.m. Our next speaker will be Mr. Sam Wei Hong, and he will be talking about Introduction to Dynamic Programming. Before we dismiss, it is still not too late to register for this year's PLN yet. If you haven't already, do scan the registration form's QR code on the screen. And remember to follow us on all of our social media platforms to stay updated on Programming League National 2025. You can find us on Instagram at Programming League and join our community on Discord through the official PLN channel. If you missed out on the workshop or would like to revisit the session, the live stream recording is available on PUCOM UM's YouTube channel. I'm Imana Raina, and it has been a pleasure to be your host. Have a great night, everyone.